Hello everybody. I wanted to make a quick video for you guys to talk about the process of rationalizing denominators, And the first thing I want us to notice is that our denominator in this fraction is irrational. It's an irrational number, right? It's a square root of a non-perfect square. So what we want to do is basically change the look of it, right? We're not going to change the value of the fraction. So what I'm going to do is I'm going to multiply by a value of 1. Right? Because anything times 1 is going to keep that number the same, right? So what I'd like to do is get rid of the radical on the bottom, and what it's going to do when I'm done is basically rewrite this fraction with a new look, same value, but easier to use, all right? Later on, we're going to be, using these answers to either, add, subtract, find perimeter of things. So here's what we're going to do. We're going to take our irrational part of the denominator, and we're going to multiply that times the numerator and denominator, top and bottom, right? And we're going to multiply the two fractions, so we're going to multiply horizontally, right? And then basically what happens is we're going to get 18 radical 2 in the numerator, and then radical 2 times radical 2, yes, that's radical 4, but the square root of 4 is just 2. So there we go, right? So successfully, when we multiply by radical 2 on the bottom, it gets rid of our radical, it makes it rational. And we do have one more step to go. We can divide 18 by 2. So that's going to leave us with a simpler version of the original, right? So 18 divided by radical 2 is the same as or is equivalent to 9 radical 2, right? A little easier to look at, a little easier to use mathematically. All right, let's try another one. Okay, feel free to pause the video, if you want to try it first and then check your answers here. But once again, I noticed that I do have a radical on the bottom. I have an irrational denominator, right? So what I'm going to do is multiply by that irrational part. Radical 3 divided by radical 3 has a value of 1, right? So once again, I'm only changing the look of the fraction, not the value of it. But now I'm going to have 21 radical 3 in the numerator over radical 3 times radical 3 is 3. And once again, I can divide the coefficient 21 with the 3 on the bottom, and we are finished with 7 radical 3. Okay, so those two are pretty straightforward, pretty simple examples. All right, but the next one here is a little bit more challenging, just a couple extra steps. But what I'd like you to notice is not every part of the denominator is irrational, right? 5 is a rational number. But here's what some students might do, and it's correct. Right? They just might multiply by the entire denominator, which will work, right? But if you think about it, I'm going to get 60 radical 3 up top, which is fine. There's going to be more steps to simplify. But what I'm going to do here is this. I'm just going to ask, hey, what is the irrational part of the denominator? And then I'm going to multiply top and bottom by that number. Watch, you'll get some smaller products here, right? 12 times radical 3 is our new numerator. Then I'm going to have 5 times radical 3 times radical 3 is 3. Therefore, my denominator, is 15. Okay? All right, now, 15 doesn't divide perfectly or a number of whole times into 12. So what I'm going to ask myself is, can I reduce 12 fifteenths? Right? And they're both divisible by 3. So 12 divided by 3 leaves me 4. 15 divided by 3 leaves me 5. And now I'm just going to kind of clean this up and simplify. I'm left with 4 radical 3 in the numerator and 5 in the denominator. We have rationalized the denominator and simplified our fractions. Okay? All right, so that brings me to our last example. All right, and I just wanted to show two different strategies, and you pick which one you like better. On the left here, I'm just going to dive right into multiplying by the irrational part of the denominator, radical 8s. Okay, on the right here, I'll come back in a second. I'm going to simplify radical 8 first. All right, in each case, though, we should get the same answers. Again, if you'd like to pause the video, give it a shot, see if you get the same things on both sides. But I'm going to start here with my radical 8s. Now, there are a bunch of steps here. So I'm going to get 4 radical 8 over 9 times 8, which is 72. Okay, I'm going to simplify first here, right? So I know, if you wanted, you could just kind of keep dividing by 2. So I could cut that in half and get 2, half and get 36. But then I can keep going and get 1 and 18, all right? So I now have radical 8 over 18, and many students will get to this point. These are good steps, but we're just not finished, right? Radical 8 in the numerator can and should be simplified, right? We can split that up into radical 4 times radical 2, right? Square root of 4 is 2. Now we are left with 2 radical 2 over 18. A lot of steps here, right? And our final answer will be 2/18 simplified is 1/9. Okay, no need to write the 1 in front, but my final simplified answer would be radical 2 over 9. Alrighty, so now let's go back and give this a shot with a different strategy. Okay, maybe you look at this and you say, hey, radical 8 from the very beginning is not simplified. So what I'm going to do here is I'm going to simplify my radical 8 first. Okay, that's going to give me, what's that now? 4 over 18 radical 2. And then maybe here, you could simplify first. I'm going to rationalize here, right? I notice I have a radical on the bottom. So I'm going to take that step here. Now, again, you can change your steps, change your order of doing things, but this is what I'm just seeing. That's what my eyes are seeing. All right, I multiply across the numerators. I get 4 radical 2. In the bottom, I get 18 times 2, but that's going to be 36. All right, now I'm going to simplify 4/36 by dividing by 4, 4 into 4 goes once, 4 into 36 goes 9, and once again, I get radical 2 over 9, which is the same. All righty, I hope this video helps.